Hello, everybody. This is Professor Hudson Zanin, and I work with University of Campinas. We are from Advanced Energy Storage Group, and we work with supercapacitors, batteries, fuel cells, and hydrogen. Solutions for mobility and stationary. Here, this video is about the proposal we plan to submit to FAPESP. This is basically three types of cell that we plan to study in a fundamental level and a manufacturing level. So we're going to study lithium-ion, lithium-sulfur, and redox flow batteries. This is the video here for our manufacturing facility, lab-scale manufacturing facility we have here at Unicamp. So we are looking for partners to make this project greater. So we could divide this project in two parts. One is related to solutions for mobility, another one for stationary. For mobility, we have a lithium-ion, which we plan to develop electrode rich in nickel, which allowed us to have high power. So the idea is that the lithium-ion is going to be charged extremely fast. And the lithium-sulfur solution is going to be used for a long-term run. In other words, as a solution that we plan to use for higher energy density solutions. We're going to present here what we're going to do, not how we're going to do this. So for how, please read the proposal. Here, we're going to basically prepare these two types of batteries in a coin cell level using organic electrolytes, which are the best solutions we have so far, but also they are flammable and have issues with handleability. So they are very bad when the humidity is, the water comes from the air, heats the electrolytes. So that's the best solution we have so far to remove the humidity, and there is some tricks we can play as well. But also we can replace completely the organic electrolytes. That's what we're going to do, and we plan to do this by reaching all solid state system, a system that could suffer a crash, a hole, a punch, and survive. That's very good for mobility, for electric vehicles, for tools, to avoid burnout. So that's very important. So we plan to, first of all, to prepare the cell in a coin cell, in a coin cell level that's smaller, cheaper to make. We can play with different types of materials, for example, carbon, metal oxides, spinels, for example, and different electrolytes as well. And it's cheaper way. If it works, if it's successful, we go for a pound cells, which is the rectangular one here in the above. This is using a smartphone and different types of cells, systems, device, and also the cylindrical cells are used in cars, electric vehicles, for example. And this is the facility we want to assemble this in this project, which is, we have been talking to several car manufacturer automakers, and these guys really are saying that the best cells for this kind of system are the cylindrical ones, which are more robust, and the modules preparation are more interesting. The manufacturing is more expensive, but there is this important advantage on the assembling the cell. So the next step, when we produce the cell, certify the cell, we're going to produce a modulus. In all this kind of system, in a cell level or in a modulus level, we're going to certify the system, the device with crash, thermal runaway, all this kind of this certification, qualification, which is important for next steps of the insertion of this technology to the market. The redox flow battery is the other solution. We have now a lab scale production. We test different electrolytes, and this technology is very promising for a stationary solution because they're very big, they're massive, the weight is important here. So, but also there's a huge gain when we can separate a charge from power here. For example, if we want to have a large tanks, so we storage energy here by oxidizing redox flow electrolytes. Then we flow this to tanks. So this tanks storage the energy. It's different from lithium ion, which is a conventional system that we intercalation ion or super batteries that we have a conversion. Here we have the oxidation of the electrolyte, and we storage here this electrolyte in tanks, and we can have massive tanks, or we could have smaller ones and have more or less energy storage, or we can have massive electrodes or smaller electrodes having smaller power or much higher power in the system. That's very promising for scalability on the off-grid system, or for a backup when you have, for example, a building that for any reason could have a power stop or electricity be off. For example, hospitals, for defense systems, this is very important. So an off-grid system for charge cars, for example, and others application. There are many others, but the cost here is very high. It's close to the lithium ion, about $800 per kilowatts hours, and that's very expensive. And but there is quite a few promising ways to reduce this, and it's moving towards $100 per kilowatts hour, and that's where we go in this project doing this. So we're moving these two technologies, lithium ion and lithium sulfur, to all solid states if everything works. That's here just a briefing from the plane, how we're going to do the electrolytes and all this kind of stuff. So read this carefully in the manuscript and the proposal. And here is a picture of a similar system of redox flow batteries. And here there's a strategy where we're going to replace vanadium, the membrane, and this kind of important parts of the system. And so that's the main idea right now. So the goal of this project is work with the electrolytes and do some basic science, do random analysis, FTIR, Rama, XRD, do gas analysis. The gas came out of the cells. We're going to be analyzed as well. We're going to do some simulations to understand the electrolyte, the flux of the cell, and we're going to prototype, as I told you guys. And I believe that's all. And we plan to reach with this project the technology readiness level 8, pretty close to the commercial available number. Okay, the budget of the project is about 3 million reals. That's the way we're going to use it. We're going to use as a funding for assembling the cylindrical lab scale equipments, and also to fund the students, the human resource, the consumable, and we have some refurbishing and technical reserve here. We were going to discuss with different companies, showing the projects, the benefits, and maybe we get them involved to put more people, more human resource, especially PhD that are not allowed to ask in this proposal, this call, and we want to put at least more 8 PhD if it's feasible, more 8 postdoc or something like that. And some consumables are very important here as well. So thank you for watching, and that's the executive presentation of this proposal.